Now I'd like to take a few minutes with you to go over our next three media we will discuss. Our next three media are three different types of selective and utilization media. These three media are going to allow us to just select between one group of bacteria compared to another, and at the same time test for the utilization of some sugar. If you recall in our last class, all of our media were utilization media. The citrate tested for the use of citrate, the urea tested for the use of urea, and the phenol red tested for the use of whichever sugar we added to the mixture. Our first media for today is called MSA. Since you are learning an abbreviation, of course, you need to know what the abbreviation stands for. MSA stands for mannitol salt agar. The name of the media tells you that it has two major components, mannitol and salt. Mannitol is a sugar, and we all, of course, know what salt is. In lecture, we learned that not all bacteria like to grow in the presence of salt, and those that do like to grow in the presence of salt are considered halophiles. The mannitol salt agar, due to its high concentration of salt, allows selective growth of only halophilic bacteria. It turns out that the most common genus that grows well in the presence of high salt is Staphylococcus. However, Staphylococcus is not the only bacteria that can grow on mannitol salt agar, and we'll see that as we go through this semester. Some textbooks will also state that MSA is selective for gram-positive bacteria. That is not true. Not all gram-positive bacteria are halophiles. MSA has a familiar pH indicator in it called phenol red. Therefore, you guys can probably predict that the phenol red in the MSA makes the plate red. And then if we have sugar use, just like we saw in the phenol red broth, the red media will lose some of its color and it will turn yellow due to a decrease in pH. If we flip the slide, I can show you what this will look like. On the bottom plate of the plate here, this is an area that bacteria were added and no growth occurred. No growth tells us that that bacteria is not a halophile. It is definitely not Staphylococcus. Here on the media we can see bacteria has been added and it is growing. Therefore we know this bacteria is a halophile. It is likely a Staphylococcus. However, you see no change in the media in this area, so we had no sugar use. In this area, bacteria is growing and the pH of the media decreased, causing the media to turn yellow. This tells us that in this area, the bacteria grew, so they were halophiles, and they used the sugar present, which is mannitol. Our second media for the day is called EMB. EMB agar stands for eosin methylene blue. Eosin and methylene blue are the two major components in the EMB agar. The addition of these two dyes, one green and one blue, allows for only gram-negative bacteria to grow. Therefore, EMB agar is selective for gram-negatives. In addition to selecting for gram-negative bacteria, this media can also tell us if the bacteria growing has the ability to ferment or use lactose. If the bacteria has the ability to use lactose, we will see a black precipitate occur. Flipping the slide, I can now show you what this would look like. In the top picture here, you can see the EMB agar itself is kind of a blood red, almost purplish color. The bacteria is growing on this plate. Therefore, we know that bacteria has to be gram-negative. In addition to growing, it is growing and it has sort of a purplish black color to the bacteria itself. So that bacteria is a lactose fermenter. This is another picture of an EMB agar that has been streaked or inoculated with three different bacteria. In the first streak here, it's hard to see in the picture itself, but this is a line of bacteria growing in a whitish color. Since it's growing, it is a gram-negative. It has no color. It is white. So it's a gram-negative that cannot ferment lactose. In our second streak, we can see the bacteria is growing, but it's growing a dark purple-black color. Therefore, this streak represents a gram-negative bacteria that does have the ability to ferment lactose. Our third streak is obviously growing, so it's a gram-negative as well. This metallic green color is characteristic of a specific gram-negative bacteria called E. coli. Anytime you see this metallic green color, it automatically indicates that E. coli is present. Our last media for the day is called MAC, or McConkey agar. McConkey agar is almost identical to EMB agar, except it is composed of different colors, so you get different color responses. It is selective for gram-negative bacteria, just like the EMB. The two components of McConkey agar are bile salts and crystal violet. If we flip the page, we can see what colors we would achieve. On this side of this plate, a bacteria was added, Micrococcus luteus, and nothing is growing. That tells us Micrococcus luteus is a gram-positive bacteria. On this side, Klebsiella pneumoniae has been inoculated. The bacteria is growing here, so this is a gram-negative bacteria. On the McConkey agar, if we see this bright pink color form, that tells us that this bacteria is capable of fermenting lactose. An analogous picture to the one we saw of the EMB here. In this streak, bacteria is growing, but no color, so this is a gram-negative. In this streak, bacteria is growing, and it's pink, so this is a gram-negative that ferments lactose. Just as we saw in the EMB, when we have E. coli growing on the MAC, it also gives us an interesting color. Not metallic green, but what we consider a cotton candy pink color will form.